Okay, hello everyone. Last class in detail we have been discussed about location of cardinal points and cardinal planes. We know in any optical system, 6 cardinal points are present. Uh, First and second focal points corresponding focal planes. Then first and second principal points. Then first and second nodal points. 6 cardinal points are present in any optical system. Location of these cardinal points in detail we have been discussed in our last class. I suggest that you just remember these equations. It will help to solve the numerical. In special case we found f1 focal length this side in input side and output side. If mu y equal to mu o, then the magnitude of focal length of both the side are equal. And also we found that the separation of principal points and nodal points are same, which is not depends upon mu I and mu o. Okay, in this class we are going to discuss to calculate the system of matrices for thick and thin lengths. This topic based on application of matrix formulation. Okay, so let us start. Before we are going to start our today's topic, first we are going to recall what we have been discussed in our previous classes. In this class where we have been discussed translation matrix for divergence, we found this matrix. If the medium is free space, then mu will be equal to 1, and the translation matrix in case of divergence we found 1 t 0 1. Here t is this distance. In case of convergence we found this matrix. Here instead of plus, minus will become up. Considering the refraction matrices, here this is the convex surface, but this side mu1 greater than that of the mu2, corresponding refraction matrix is this one, 1 0 minus 1 by r, mu1 by mu2 minus 1, mu1 by mu2, 0 mu1 by mu2. In case of mu1 less than mu2, considering convex surface itself, we found the refraction matrix is this one, 1 0 1 by r, mu1 by mu2 minus 1, mu1 by mu2. In case of concave surface, the refraction matrix we found 1 0 1 by r, mu1 by mu2 minus 1, mu1 by mu2. Okay, so if I'm going to consider the determinant of all of these refraction matrices, we can found mu1 by mu2, because this element is 0. The determinant of these matrices always will be mu1 by mu2. Instead of mu1 we can write mu I, which is I represents the input side. Instead of mu2 we can write mu o represents output side. Considering the special case, refraction by plane surface, r radius of curvature will be infinite, and the refraction matrix we can found 1 0 0 mu1 by mu2. In system of matrix of an optical system class, we discussed that system of matrix SM act as an operator which operates on initial information, that is your object information. We can found the image information. This I represents the input, O represents the output. Input means object, output means image. In detail we have been discussed. The system of matrix act as like a operator. Okay, act as like a operator. In general, system of matrix of any optical system can be written in this format, A, B, C, D, which is a 2 cross 2 matrix. Okay, considering this figure, if I'm going to consider this figure, and particularly if we want to find out the system of matrix of optical system, here if this is a thick lens is optical system, then for this thick lens, one refraction, one translation, and one refraction. So the system of matrix will be for this optical system will be refraction, translation, refraction matrices multiplied with each other. After multiplication also we can get 2 cross 2 matrix. In detail we have been discussed. Okay, now we are going to start to discuss our today's class calculation, or to calculate the system of matrices for thick lens and thin lens. First we have to calculate for thick lens, then we are going to go for the thin lens. Okay, so to calculate the system of matrix for thick lens, consider this figure. In this figure you can see a thick lens having thickness approximately t, enclosed by two surfaces 1 and 2, I and 2i. This is one surface and this is another surface. In between these two surfaces, a thick lens having thickness t enclosed, having refractive index. Thick lens having the refractive index is your mu2. Left side of this system, see, enclosed by these two surfaces, this is called as your system of matrix of a optical system. Optical system means your thick lens. So left side of this optical system is called as your input side. Input side having the refractive index mu I. Right side of this optical system is called as your output side or output plane having refractive index mu O. Here it is considered that both left side and right side having refractive index is same, mu1, and this side also mu1. And here the refractive index of the thick lens considered as mu2. So this side is your mu1, this side also mu1 refractive index, and thick lens having the refractive index mu2. And mu2 is greater than that of the mu1 here. You just imagine that this is the lens, thick lens made up of glass having refractive index 1.5 around. Left side of this thick lens is your suppose air medium, and this side also air medium having refractive index 1. Okay. Now we are going to write in general the system of matrix of this optical system. Here optical system is your thick lens, and this A and A dash represents the initial information or object information, and this D dash represents the image information. So here initially ray starts from A and interacts at B. So this is the translation outside of this optical system. At B, one refraction happens, that is your refraction Rm1, right? Then from B to C the ray translates. So this is your another translation. The first translation is represented as T1, the second one is your T2. Then at C another refraction happens, that is your Rm2. Then translation happens from C to D, that is your T3. So here how many matrices required to represent full dynamics? We need 5. 1, 2, 3, 4, 5. But if we are going to consider strictly for thick lens, you just recall when that video where we discussed specially system of matrix of an optical system, this video, you go through that video. There we discussed that system of matrix of optical system considering thick lens is your this one, Rm2, second refraction, here second refraction, then T2, second translation. The translation happens inside the optical system, then fast refraction, then fast refraction. So in this way we have to multiply first refraction 2, then translation matrix, then refraction 1 matrix. So system of matrix of thick lens here according to this figure will be multiplication of these three matrices in this order. You could not say I can multiply like this. No, it will be correct. It will be incorrect. It could not be correct. So it has to multiply like this. First Rm2, then translation, then refraction, fast refraction matrix. Obviously after multiplication this will be a 2 cross 2 matrix that we can evaluate here. So first I am going to write the second refraction matrix here. Second refraction matrix means here at concave surface, refraction is your second refraction here. This is your Rm2 and this is your so-called Tm2 translation, second translation, and at this point first refraction happens. So first we have to write second refraction matrix. Here I written how and why. I have been written over here this value. Here I am going to show you. Consider this one carefully. You just watch. Consider this one, refraction at concave surface. Here, this side is your mu1, this side is your mu2, and here mu1 greater than that of the mu2. And for this case, refraction matrix is what? 1 0 1 by r, mu1 by mu2 minus 1 mu1 by mu2. So here mu1 is the refractive index of this side, concave side, medium which is in the concave side, and mu2 which is in the convex side. You just compare this figure here. If I'm going to consider refraction at C, then concave side the refractive index is what? Mu2. But here concave side refractive index is what? Mu1. But here mu1 is greater than mu2. The condition is same here. Here mu2 is greater than that of the mu1. That means concave side refractive index greater than that of the convex side refractive index. So refractive index condition satisfied. But if I'm going to compare this situation with this situation, then instead of mu1 mu2, here it is written. So here for this case, the Rm refraction matrix is your 1 0 1 by r, mu1 by mu2 minus 1 mu1 by mu2. If I'm going to compare this situation with this one, then for this case the refraction matrix will be 1 0 1 by r2. See here r2 is represents the radius of curvature of second surface. So this is the second surface, this is itself a curve, so radius of curvature of this second surface or curve is your r2. 1 by r2 mu2 by mu1, because in your concave side what is the refractive index? Mu2. In your convex side here refractive index is mu1, so mu2 by mu1 minus 1 mu2 by mu1. Same, see here we have been used the same concept, but here in the concave side mu1 is there, and in your concave side mu2, instead of mu1 mu2, here in our figure the refractive index is your mu2 mu1. Only for that here I written mu2 by mu1 and mu2 by mu1. Got it? Okay. Now translation. This translation happens in the medium. This medium having the refractive index mu2. What is the thickness covered? Approximately t. So you just recall the translation matrix. Where is the translation matrix? Here is the translation matrix. If translation happens in a medium, then the translation matrix is represented as like this. If this is divergence 1, then translation matrix will be 1 t by mu. This distance t by mu, the refractive index of that medium, 0 1. Same thing I have been written over there. Instead of mu I written mu2, because the medium, that means the refractive index of this thick lens is your mu2. So 1 t by mu2, because here thickness, this ray traveled from B to C, approximately thickness how much? T. Okay, so t by mu2 0 1. Okay, then we are going to go for the writing the refraction matrix at B. Here at B you just consider this one. Here mu1, this case is your mu1 greater than mu2. No, we have to consider mu2 greater than that of the mu1. This side refractive index greater than mu1, then refraction matrix is your 1 0 1 by r. That means this surface radius of curvature, mu1 by mu2 minus 1 mu1 by mu2. Same I have been written over here, 1 0 1 by r1. Here r1 is the radius of curvature of first surface. Okay, mu1 by mu2 minus 1 0 mu1 by mu2. Okay, now we are going to just solve. First we have to multiply these two matrices. Here you can see 1 multiplied with 1, written 1, plus this t by mu2 multiplied with this much factor, written over here, right? Then this row multiplied with this column. So what we can found? 1 into 0 0 plus t by mu2 multiplied with mu1 by mu2, written over here. Okay, then this row multiplied with this column, written over here, 0 plus 1 by r1 mu1 by mu2 minus 1. Then this row multiplied with this column, written over here, 0 0 plus 1 into mu1 by mu2, written over here. Okay, now we are going to multiply these two matrices in our next slide. Here first I written the same again, these two matrices same, this one and this one I written again. and then I remove these zero values. Okay, I rewritten this matrix again here. Okay, then I multiplied these two matrices. Here you can see this row multiplied with this column. Carefully, you just watch. 1 multiplied with enter this term written over here. Then 0 multiplied with this term will be 0 plus 0. Okay, okay. Then this row multiplied with this column. 1 multiplied with this one written as such. 0 multiplied with this one, 0 plus 0. Okay, okay. Here this row multiplied with this column. Carefully, you just watch this row. That means this term multiplied with this one written here, 1 by r2, 1 by r2, mu 2 by mu1 minus 1, mu 2 by mu1 minus 1 into entire this term written over here, 1 plus t by mu2 into 1 by r1 into mu1 by mu2 minus 1. Then this term mu2 by mu1 will be multiplied with this one plus mu2 by mu1 multiplied with this one. Okay, okay. Then again this row multiplied with this column and written over here, this one, right. And in the next step I just remove these zero values and I rewritten the above matrix here. So here what we found the system matrix of thick lengths in general. In general, this matrix is represents the system matrix of a thick lengths, which is itself a 2 cross 2 matrix. 2 cross 2 matrix means this is one element, this is another one, this is one element, this one and this one, 4 elements. Okay, okay. Now I suggest that if you can, you just remember this one, this system of matrix for thick lengths. It will be useful for thick lengths as well as thin lengths also to solve different numerical. Okay, okay. Now I just written what we found here, system of matrix of thick lengths again over here. Then we are going to simplify by considering mu1 equal to 1 for vacuum. That means this side we consider as mu1 is your vacuum, and mu2 here by mistake I written this should be mu2 equal to mu. Then above equation will be, here you can see this side, that means input side mu_y considered as mu1, output side also mu1. Here we consider both the side, input side and output side is your air medium. Okay, air medium. So obviously for air medium this mu1 value will be 1, that we have to substitute in this 2 cross 2 matrix. And here we consider mu2, the refractive index of the thick lens considered as mu. Then the above equation will be, here you can see if mu2 considered as mu and mu1 is your 1, so mu2 by mu1 will be 1, will be mu. Now here we have to substitute these values, mu2 by mu1 equal to mu and mu2 equal to mu. So this is your 1 written as 1 plus p by mu2. So instead of mu2 we have to write mu. Okay, 1 by r1 written as such. Here mu1 by mu2 is nothing but 1 by mu2 by mu1, and mu2 by mu1 is nothing but mu. So this mu1 by mu2 can be written as 1 by mu. Okay, minus 1. Okay, okay. Then here t by mu2 will be written as what? Mu. And mu1 by mu2 will be written as what? Here mu1 by mu2 will be written as 1 by mu. Okay, because mu2 by mu1 is your 1, mu1 by mu2 is nothing but 1 by mu2 by mu1, where mu2 by mu1 is nothing but mu, so mu1 by mu2 is nothing but 1 by mu. Okay, so here this mu1 by mu2 is your 1 by mu and this mu2 is your mu, so this will be t by mu square. Okay, okay. Now similarly here mu2 by mu1 will be written as mu minus 1 plus t by mu2, 1 by r1, mu1 by mu2 will be written as 1 by mu minus 1, mu2 by mu1 will be written as mu, 1 by r1 1 by r1. Mu1 by mu2 will be written as 1 by mu minus 1, and this term here 1 by r2 mu2 by mu1 will be written as mu minus 1. Here t by mu1 by mu2 is nothing but 1 by mu, this mu2 is nothing but mu, so it will be written as t by mu square plus 1 is there plus 1. Okay, okay. Now same thing I written over here for further simplification. In the next slide, first I written this matrix again. Okay, here. Okay, for further simplification. So that implies system matrix of thick lengths will be written here, will be written as 1 plus t by mu 1 by r1. Here 1 by mu minus 1 will be written as 1 minus mu by mu. Okay, okay. T by mu square written as such. Here 1 by r2 mu minus 1, 1 plus t by mu, 1 plus t by mu, then 1 by r1, 1 by mu minus 1 will be written as what? 1 minus mu by mu, plus mu 1 by r1, 1 by r1. Here 1 by mu minus 1 will be written as 1 minus mu by mu. Again here 1 by r2 mu minus 1 written as such, this term t by mu square plus 1. Okay, okay. Now we know that power for faster refracting surface means this one, and second refracting surface means this one. Power for faster refracting surface P1 is nothing but your mu minus 1 by r1. Power for second refracting surface is your 1 minus mu by r2. Okay, so instead of these values mu1 minus 1 by r1, sorry, mu minus 1 by r1 and 1 minus mu by r2, we have to substitute p1 and p2. So here in general already we know a system of matrix is represented by a, b, c, d. So that I am going to substitute instead of mu minus 1 by r1 as p1. Here you can see 1 plus t by mu written as such. Here you can see 1 by r1, here 1 by r1, mu minus 1. If I'm going to take common minus, so it will be 1 minus mu. So minus of 1 minus mu by r1 is nothing but your what? P1. So minus is there, so obviously it will be minus p1. So instead of 1 by r1 into 1 minus mu will be written as what? Minus p1. Okay, so this plus will be minus t by mu is there, t by mu. Then this value I told that this much 1 by mu by r1 is your p1 minus p1, and this mu written as such. Okay, okay. T by mu square written here. Then 1 by r2 1 minus mu is your p2. Here 1 by r2 mu minus 1 is nothing but what? Minus p2 written here. Then 1 here 1 minus mu by r1 will be nothing but what? Minus p1. Minus p1 means this plus will be minus here. T by mu is there, t by mu I written as such, p1 by mu. Okay, okay. Then then here mu got cancelled. 1 minus mu by r1 is nothing but p1 written as such. Sorry, 1 minus mu by r1 is your minus p1, because p1 is your mu minus 1 by r1. So 1 minus mu by r1 is minus p1 written over here. Okay, then this term here 1 by r2 mu minus 1 is nothing but minus p2. T by mu square written as such plus 1 written as such. Okay, okay. Then for the after simplification we can get 1 minus t into p1 by mu square. Mu is your mu square, t by mu square. Here this term, carefully you just watch this term here, we can get this is minus p1, here minus p2 into this term. Just I written minus p1 first. Okay, okay. Then this one is written as 1 minus t into p2 by mu square. Let this is your equation number 1. Now we are going to go for further simplification. Equation number 1 I rewritten in this slide. Then we have to simplify further. Here in general, that we know, in general system of matrix is represented by Sm for any optical system. In general, the system of matrix of an optical system, you just write of an optical system in your note. Okay, is represented as SM equal to ABCD, right? And we know that P1 is this much, P2 is this much. And for mu I equal to mu O, then F1 equal to 1 by C and F2 equal to minus 1 by C, where F1 and F2 are the first and second uh, focal lengths of the lens or an optical system. Okay, these things already we have been discussed. For mu1 equal to mu2, f1 will be equal to 1 by c, f2 equal to minus 1 by c in our last class. I'm going to show you that uh, that slide. Here you can see in our last class we discussed the uh, location of cardinal points. Here you can see in that class what we discussed that when mu1 equal to mu2, f1 equal to minus f2, and f1 value is your what here, when mu1 equal to mu2, so this value will be 1. So f1 value is your 1 by c, f2 is your minus 1 by c. So f1 equal to minus f2, that we discussed in our last class. Same thing I have been written over here. Okay, same thing I have been written over here. For that means here previously we found in our previous class, in our previous class, you just write in a note. In our previous class we found, we we know for mu1 equal to mu2, f1 equal to 1 by c, f2 equal to minus 1 by c, where f1 and f2 are the first and second focal lengths of optical system, here thick lens or any lens. Okay, okay. Hence, by comparing, see here, this is the system matrix of thick lens. This is the system matrix of general in general optical system. Okay, so if I'm going to compare this system matrix and this system matrix, here A equal to this much, B equal to this much. This is your A value, this is your B value, this value is your C, right? And this value is your D, right? This value is your D. So now if we are going to consider our previous class, if I'm going to consider our previous class we found in general the focal length or focal lengths of first and second focal lengths of a optical system is your 1 by c and minus 1 by c. Both magnitude are same, 1 by c and minus 1 by c. So by comparing this system matrix and this system matrix, the focal length of this one will be how much? The reciprocal of this value, because this is your c. If I'm going to consider the magnitude of the focal length, f1 magnitude, which will be equal to f2 magnitude, this will be equal to 1 by c. Okay, so here 1 by c means reciprocal of this value. Okay, same thing I'm going to write over here. Also I written in the note itself, you just watch. So hence by comparing above two matrices, we can write what we can write here. Here you can see this is your c value, right? This is your c. So f2 equal to minus 1 by c. So we can write minus 1 by f2 equal to 1 by c, right? Simply. So minus sorry minus 1 by f2 equal to c, sorry, minus 1 by f2 equal to c, or f2 minus f2 equal to reciprocal of c. So here if I'm going to consider this one, then uh, minus 1 by f2 will be equal to c. Okay, same thing here I written minus 1 by f2 equal to this value c in your equation number 1. Carefully you just watch, these are most important points you should understand. So that implies minus 1 by f2. Here see, f2 means second focal point, which is this focal point is present right side of this optical system, f1 present left side. So here this f2 represents right side of this optical system. So here we found minus 1 by f2 equal to this much. Here I just simplified, minus p2 multiplied with this one, minus p2 multiplied with the second term I written as such. That implies 1 by f2, this minus multiplied with all the terms of RHS. We found p1 plus p2, here plus is there, so minus p1 into p2 into t by mu square. So here what we found, here reciprocal of focal length of thick lens, this is nothing but reciprocal of focal length of a thick lens, which represents the power of optical system, or in this case we consider the thick lens. This represents the equivalent power P, capital P, which is equal to P1 plus P2 minus P1 into P2 into T by mu square. You just remember this expression. Okay. In the next slide, I written again this equation number 1, and in general we know the system of matrix is your ABCD. Just compare these two matrices. What we can found? Already P1, P2 I written. Okay, this one. In general, P1, P2 is this much and this much. A value is your this much. B value is your T by mu square. C value is your this much. D value is your this much. From our last class, what we found? Last class we found this one, x1 equal to d by c, x2 equal to minus a by c, r1 equal to d minus mu1 by mu I by mu o by c, r2 1 minus a by c in your equation number 17. Z1 and Z2 values are this one and this one, F1 and F2 values are this one and this one and this one in your equation number 10 and 15. That means this x1 and x2 represents what? First and second focal points from input and output planes. R1, R2 represents the first and second principal points from input and output planes. Okay, 20 and 21, 22. This one is your 22, right? This one is your 22. First, I have to correct it. This 20 and 22 represents the first and second nodal points, and here 10 and 15 equations represents the first and second focal points from the principal points, corresponding principal points and their magnitudes. If I am going to consider these magnitudes, both are same value. Sorry, if I am going to consider the magnitudes, then we can found the focal lengths, first and second focal length. But if I am going to consider this side refractive index is equal to this side refractive index, both are AR medium. If mu1, mu I equal to mu o, if mu I equal to mu o, for mu I equal to mu o, then what we can found here? Mu I equal to mu o, that means this value will be 1. This value will be 1, equation number 16. Then here mu I equal to mu o, in equation number 22, this value will be 1. Mu I equal to mu o, this value also 1. Okay, 1. So here we found when mu I equal to mu o, this side and this side refractive index indices are same, then these are the equations. So I suggest first you just remember these equations, which are most important to solve different questions. Okay, now we are going to move our next slide to solve a question based upon these equations. Okay, so here we found this is the final system of matrix of the thick lens, this one. So by using, and if I'm going to consider this this matrix and this matrix, the corresponding A, B, C, D values are this, and P1 value is this one, P2 value is this one. So if I know mu value, refractive index of the optical system or thick lens, R1 and R2 value, we can evaluate P1 and P2. Then also we can evaluate A, B, C, D. Then by using these equations, we can find the cardinal points of a thick lens. So here I written the calculation of the location of the cardinal point of thick lens. So these are the cardinal points of the thick lens in general. If mu I equal to mu o, if mu I not equal to mu o, then these are the cardinal points. So here again I suggest that you just remember these values for mu I equal to mu o, because most of the time in your question it is given that mu I equal to mu o. That means both input and output side refractive index are same in your question. Okay, so to solve a question, very important that you have to remember these values. Now we are going to go for a question based upon these equations or these values. Here, a thick lens of a material of refractive index 1.5 and radii of curvature of two surfaces plus 10 centimeter and minus 15 centimeter. So here R1 given that plus 10, R2 given minus 15 centimeter. Locate the cardinal points if the thickness is 5 centimeter. Thickness, okay, thickness is 5 centimeter. I have to correct it. This is your thickness. If thickness is 5 centimeter, we have to find out the cardinal points, right? Here you can see solution starts. Given refractive index of the optical system means this one is your how much 1.5. Radius of curvature of two surfaces is your R1 this much, R2 this much. First we have to calculate P1 and P2. P1 mu minus 1 by R1, 1 minus mu by R2. So P1 we found 0.05, P2 we found 0.03. Then A value is how much? A value is 1 minus T into P1 by mu square. Calculate this one. You just substitute these values. T we found T given 5 centimeter. You just substitute these values. You can found A is your 0.89. Likewise B you can found 2.22. Then calculate C value. C is nothing but your minus P1 minus P2 into 1 minus T P1 by mu square. Here I written, you just put all the values. P1 value you found here, we found 0.05, P2 0.03, substituted 1 minus T is 5, P1 this one, then mu square. You just solve it, you can found C value is this much. Okay, here A value is this much, B value is 2.22, and D value like that you just solve, calculate, you just found this much. Okay, no need to write the unit now here itself. At the end, whenever we are going to calculate the cardinal points distance from one input plane or whatever, at that time we have to put the unit. So here we found the A, B, C, D values. Now here I written separately. Okay, now x1 is D by C, x2 minus A by C, f1 1 by C, f2 minus 1 by C. First you just calculate x1, D by C, this one minus 12.17 centimeter. You just recall at that time I told that here x1 we found plus, but x1 is your negative. X1 is represents the focal location of focal point from the input plane towards left, but in general this value is your positive, but after solving this question we found this value is negative. That means this value, this negative value represents that we have to move from the input plane towards left. How much distance? 12.17 centimeter. Then we can found the first focal point, right? Then x2, here x2 is the second focal point from the output plane towards right. This x2 is nothing but minus A by C. Just put the values. A value is this one, C value is your minus value. So you found 11.6 centimeter. So this positive value represents that we have to move from output plane towards right. How much distance? 11.6, and we can found the point F2, second focal point. Now calculate F1. F1 means 1 by C. 1 by C means here we found minus 13.03 centimeter. This represents what? F1 and F2 represents what? First and second focal lengths. From first and second location of, from first and second principal points. Okay, that means location of this one F1 from P1 towards left. Okay, obviously here we got the negative value. That means from P2, from principal point or principal plane, we have to move towards left. How much distance? Minus 13.03 centimeter. And here F2 value will be same magnitude but opposite sign, 13.03. That means we have to move from P2 towards 13.03 centimeter towards right, and we can found the second focal point. R1, you just calculate the R1 value. R1 means D1 minus D minus 1 by C, and here R2 1 minus A by C. Just substitute the D, C, A value. Here we can found R1 equal to 0.86 centimeter, R2 is your minus 1.434 centimeter. So R1 is what? R1 is your location of a first principal point from input plane. Okay, that means if this is your input plane and we are going to locate the first principal point, that means we have to move towards right. Here you got the positive value. That means we have to move 0.86 centimeter from input plane towards right. We can found first principal point and second principal point. This R2 represents we have to move from output plane uh, towards left. How much distance? Minus 1.434 centimeter, and we can get how much? We can get the second principal point. Automatically the values came. Okay, this came as plus, this came as minus. That means here I written itself 16 17 represents what? Location of first and second principal points from input and output planes. So here for first principal point from input plane means we have to move towards right. Here from output plane we have to move towards left. Okay, now we have to just verify whatever we have been calculated, it is correct or not. You just calculate x1 plus r1, this distance x1 plus r1 distance should be equal to x2 plus r2 distance, because here we found f1 magnitude equal to f2 magnitude. Here x1 plus x2 we found 0.03 centimeter, x2 plus r2 is your 13.03 centimeter, here 13.03 centimeter. So what we calculated over here, location of principal point and focal points all are correct. Now we are going to go for our first and second nodal points. Actually these equations are 20 and 22. Just wait, this is your 22. Okay, this is your 22. So from 20 and 22 the equation number 21, 20 and 22 represents the first and second nodal points, that is your d minus 1 by c, 1 minus a by c, and r1 r2 also same. Okay, so here what we conclude, what we found, the location of first and second nodal points are coincide with the first and second principal point. Obviously these are same. Okay, these are same here itself. D minus 1 by c, 1 minus a by c for mu I equal to mu o. If mu I not equal to mu o, then it will different. Okay, okay. So here we solve this question. Now we are going to move to calculate the system of matrix for thin lengths. Here I am going to stop this class. In the next class we are going to discuss this topic. Okay, otherwise this video will be too long. So in the next class we are going to discuss calculate the calculation of system of matrix for thin lengths. Okay, so thank you so much for watching this video. Thank you.